Hey, year 11. So we've just looked at number patterns and what different sequences were. There's actually a few different types of sequence, and one of them is arithmetic sequences, which is what we're going to be looking at today. So you might have noticed that in a couple of the examples from the previous video, um, some of them went up or down by the same amount each time, where other ones, it wasn't the same amount each time. They might have been halved or doubled. But this time, with arithmetic sequences, we're going to be looking at those, and they're the sequences where you add or subtract from the previous number. So it's going up or down by the exact same amount each time. And there's something important when it comes to arithmetic sequences, and it's called the common difference, and we use the letter D to show it. And it's the amount that we add or subtract each time, so to get to the next term. So there's a couple of examples that I've got written down here. So if the sequence keeps on going up by 2, then the common difference, or D, is 2. If the sequence keeps going down by 5, then the common difference would be minus 5. Okay, so if you're going up, you're going to have a positive common difference. If the sequence seems to be going down, you're going to have a negative common difference. So let's have a look at the next couple of examples here and do them together. It's asked for us to find the common difference. So if we look at this one here, we can see that we're going from 1 to 11 and then to 21. Hopefully we can see that we're going up by 10 each time. So the common difference of this sequence would be 10. That's all we need to do. So let's look at the next one, B. Okay, we start at 15, we're going down to 12, then 9, then 6 and 3. It looks like we're going down by 3 each time. So that would mean that the common difference would be minus 3, because we are minusing 3 from the term before it. Okay, now you can do this. You can generate sequences really fast using your CAS, as I've dot pointed here. I'll show you that at the end of this video though. So let's keep going for now. One of the things that you might be asked to do is graph sequences. So we've got this sequence here that we've been given. I've already written a table up for you, but it can actually be a good idea to draw these tables up if you've been asked to graph, because it is a bit easier to kind of transfer between a graph and a table. But what this table is showing is that we've got the different term numbers, so first term, second term, third term, fourth term, fifth term, so first, second, third, fourth, fifth, and then the value of that term. So the first term has a value of 1, the second term has a value of 3, the third term, which is that one, has a value of 5, and so on. We can move those sequences into a table, but what we're really supposed to do is graph it. Okay, so what I've set up here is a set of axes down the bottom, and it's always going to be this down the bottom. It shows the term number. So this here is representing the first term, then the second term, then the third term, fourth term, fifth term. That's why I've labeled it with N, term number there. And this axis here, the y-axis, that's going to be showing the term's value. Okay, so I want to move this information into here. Okay, so one thing that I should do as well is make sure I label that axis, so that's TN. Alright. Now the first term, we have a value of 1. So first term, value of 1, there we go, we've got our dot. Second term, which will go here, has a value of 3. That's around about there. The third term has a value of 5. Something like that. The fourth term has a value of 7. 7's there. Fourth term's about there. Might be a bit easier if you're using graph paper or line paper. And our fifth term is 9. So fifth term and 9 is going to look like that. Do we see how all our dots seem to be in a straight line? If it's an arithmetic sequence, they should, and you graph it, they should look like they're in a straight line, just like that. One of the things that you might be asked to do as well after graphing is describing the graph. Now, the main thing you need to do is say whether it has a positive or negative slope. Okay, so we would just say that the graph above has a positive slope. and that's all we need to do. Alright, now I'll show you how to generate those sequences on your CAS.
Alright, to generate sequences using your calculator, firstly open up a calculator document, so that one there. Let's just start with a starting value of 10. So what you need to do is just type in whatever that value is, press enter. Now let's just say we have a common difference of 2, so we want the sequence to be going up 2 each time. What you do now is write in plus 2. You see how that answer comes up there? That's what we want. And press enter. So 12 is our next term. Now you don't necessarily have to write or type anything in to get the next terms. All you need to do is keep pressing enter. So if I press enter, it keeps on adding what I want. So you can work out a really, late term or large term just by pressing enter a whole heap of times. So it can be pretty quick and easy if you do that. Thanks, guys.